Hello, our dear students. Our lesson today about solving first degree inequality in one unknown. Now, properties of the inequalities. Inequalities have many properties in common with equation. The following properties will be used in solving first degree inequalities in one unknown. Number one, the same number can be added to each side of an inequality without changing the solution of the inequality. For example, if x minus 1 bigger than 3, here we can get rid what? Negative 1 or minus 1. How? To add 1 to each side. So I add 1 to each side. So x minus 1 plus 1 bigger than 3 plus 1. So we can cancel 1 and negative 1. Then this term will be x bigger than, the next term is 4. Then the solution set in Z will be, here the solution set is all integer which are greater than 4. Okay, I want all the number greater than 4. So the solution set in Z will be 5, 6, 7, 8, and so on. It's infinite set. Number 2, the same number can be subtracted from each side of an inequality without changing the solution of the inequality. For example, if x plus 1 less than 5, we can get rid plus 1 by subtracted each side by 1, by subtracted 1 from each side. So the answer will be x plus 1 minus 1 smaller than 5 minus 1. And we can cancel positive 1, negative 1. So x less than 4. Here, the solution set all integers which are less than 4. So the solution set will be 3, 2, 1, 0, negative 1, negative 2, and so on, and it's infinite set. Number 3, the same positive number can be multiplied by each side of an inequality without changing the solution of the inequality. If x divided 2 bigger than 2, we can get rid 2 by multiplying the two sides by 2, multiplying each side by 2. So the answer will be x divided 2 times 2 bigger than negative 2 times 2. We cancel 2 and divided 2. So x bigger than negative 4. So here the solution set is all the integers bigger than negative 4. So the answer will be, the solution set is negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, and so on. It's infinite set. Number 4, each side of an inequality can be divided by the same positive number without changing the solution of the inequality. For example, if 3x less than negative 15, here we can get rid 3 times by dividing each side by 3. So 3x divided 3 less than negative 15 divided 3. So x less than, we cancelled 3, then x less than negative 5. So here the solution set is all the integers less than negative 5. So the solution set in Z will be negative 6, negative 7, negative 8, negative 9, and it's infinite set. Number 5, if we divided or multiply each side of an inequality by a negative number, we must reverse the inequality. As the example, if negative 2x bigger than 6, we can get rid negative 2 times by divided the two sides by negative 2. But here we said, if we divided by negative number, we must reverse the inequality. So this is negative 2 by divided each side by negative 2. Number 1, don't forget to reverse the sign. This is bigger than, so we reverse it to less than. So negative 2x divided negative 2 less than 6 divided negative 2. So we cancelled negative 2 and negative 2. So x less than negative 3. And the solution set is all the integers which are less than negative 3. The solution set in Z will be negative 4, negative 5, negative 6, and so on. It's infinite also set. Exercise, find the solution set of each of the following inequalities, then represent the solution set on the number line. Number 1, 2x minus 5 less than or equal negative 7, where x belongs to Z. Now we solve this exercise. Solution, 2x minus 5 less than or equal negative 7. We get rid negative 5 by adding 5 to the both sides. So 2x minus 5 plus 5 less than negative 7 plus 5. We cancel positive and negative 5. The answer here will be 2x less than or equal negative 2. It's finished? No. Why? Because we said before, to get the solution set, we must find the variable alone without any number beside it or over it. Okay? So we will complete these questions. Since 2x less than negative 2. Here we get rid 2 times x by dividing the two sides by 2. So the answer will be 2x divided 2 less than or equal negative 2 divided 2. And we cancel the 2 up and down here. So the answer will be x less than or equal negative 1. And the solution set is all integers which are less than or equal negative 1. So the solution set in Z will be, we take negative 1 because it said to me less than or equal. So negative 1, negative 2, negative 3, negative 4, and so on. It's infinite set. But now I want to represent this set on the number line. Number 1, we draw by using the ruler, number line, and distribution the number as this. Okay? And represent this solution set. Negative 1, negative 2, negative 3, negative 4. And I said it's infinite set. But infinite set in negative directions or in positive directions? In negative directions. I complete in the negative set or in the negative integer or in the negative integer. Okay? So the arrow will be in the directions of your left hand. Okay? Number 2, 1 minus 8x less than 33. Solution. Here I get rid number 1 by subtracted 1 from each side. So the answer will be 1 minus 8x less than 33 minus 1. I cancel positive and negative 1. So the answer will be negative 8x less than 32. And we will complete these questions. negative 8x less than 32. Here we get rid negative 8 by dividing the both sides by negative 8. But before here, we said when we divided by negative, we reverse the sign of the inequality, or we change the directions of the inequality sign. Okay? So here the answer will be negative 8x divided negative 8. I reverse the sign from smaller than to the bigger than. 32 divided negative 8. So here I cancelled negative 8 and negative 8 up and down. So x will be bigger than negative 4. So here the solution set is all the integer number which is greater than negative 4. So the solution set is negative 3, negative 2, negative 1, 0, 1, and so on. So I representing on the number line, I draw the number line and represent it negative 3, negative 2, negative 1, 0, 1, 2, and here I draw the arrow in the positive direction of that positive. Exercise, find the solution set of the inequality to x plus 5 less than 11, where number A, x belongs to z, number B, x belongs to natural number n. Solution, 2x plus 5 less than 11, I get rid plus 5 by subtracted both term by 5, okay? So 2x plus 5 minus 5 less than 11 minus 5. I cancelled positive and the negative, so the answer will be 2x less than 6. And we will complete this question. X less than 6. Here I get rid 2 times x by dividing both terms by 2. Okay, so 2x divided 2 less than 6 divided 2. I cancelled 2, so the answer will be x less than 3. So the solution set is all here. I want the solution set in n and in z. At first in z, in the integer numbers, the solution is all the integers which are less than 3. So the solution set in z is 2, 1, 0, negative 1, negative 2. But I want the solution set in the natural number. So the solution set is all the natural number less than 3. So the answer will be 2, 1, 0 only, okay? Because the natural number starts with 0. So I want all the natural number less than 3. So I write 2, 1, 0. Okay? Thanks for your listening.